To talk on the topic of variation. Then, through this topic, by the end of this topic, you have to know the meaning of variation, types, and examples. What is variation? Variation is the relationship between two or more variables. That's the meaning of variation. Then, considering x varies y, it can be rewritten as x is proportional to y. Mathematically, it can be expressed as x is directly proportional to y. That's x with this sign in quotes. This is the proportional sign to y. Then there's always a constant in variation, either k or c, because that's the most used constant in variation. Then if you heard me earlier, that's proportional sign. This is it here. Then here it's telling us that it can also be otherwise named as proportionality. Yk is the constant, x and y or a and b is the variable. Types of variations: we have direct variation, indirect variation, or inverse variation. They are the same thing. We have joint variation, combined variation, and partial variation. But in this video, I'll be talking more on the direct and the indirect variation. What is direct variation? Direct variation is a type of variation of a variable with another variable with another derivable quotient called constant if y varies directly as x. That's the sign I talked about earlier in the previous slide. If that's y varies directly as x, then y is equals to the constant will appear. Once you remove the proportional sign, it will be the alphabet at the front is equals to the constant, then your variable. This is the equation of the direct variation. Then y and x are variables, k is constant, as I have explained. Note, constant has to be alone so you can use it for change of formula. Yes, this k, it has to be alone, meaning that it will be k is equals to xy. So you'll be able to look for the k, because k is the first value you will look for in variation. Examples of direct variation. I'm explaining one example. If y minus 5 is directly proportional to x raised power 2 and y is equals to 7 when x is equals to 2, find x is equals to 3. That is, y minus 5 is directly proportional to what? X raised to power 2. That gives us y minus 5 is directly, then you add your constant to the x raised to power 2, because that's the receiving end. Then using the constant required method, because there are two methods in solving this, but I'm explaining one. There's the direct method and the constant required method. Using the constant required method, y minus 5 is equals to constant k raised to power x raised to power 2. Then the second one, 7, if y, using y is equals to 7, where you see y you put 7. 7 minus 5 is equals to where you see x you put 2, because we are looking for the k, so we have to impute those values to get the k. So 7 minus 5 is equals to 2 raised to power 2k. That's k. When you collect use k as subject of formula, k is equals to 2 over 4. That's 1 over 2 or 0.5. Then he said find y when x is 3. So going back to this general equation, y minus 5 is equals to 0.5 x raised power square x raised power of 2. Then find y when this x here is 3. That's y minus 5 is equals to 3 3x square. So as I'm y minus 5 is equals to 0.5, that's the constant k that we looked for previously, times 3x square, 3 square, that's the x, the 3 is already representing the x. So y minus 5 is 0.5 times 9, so y minus 5 is equals to 4.5. If we collect like terms, bringing this minus 5 to the other numeral, that's y is equals to 4.5 plus 5, then y is equals to 9.5. When x is equals to 3, y is equals to 9.5. so we have gotten the y, and how we got the y is by first finding the k. X, y, you can say mathematically, you can say y varies inversely. Inversely is always having 1 over the variable you want to use. That's what inverse is all about, 1 over the variable. So y is equals to k, where you put that one, you change it to k over the variable. And as I said in the direct variation, you collect the k is always the subject of formula, so k is equals to xy. Then knowing that x and y are the variables, yk is constant. I will talk about one example now on the inverse variation for us to understand more. The example goes like this: the number of carpet tiles on the floor varies inversely as the square of the length of a side of a tile. For 2016 tiles, size 0.4 was used. That's for 2016 tiles, size 0.4 was used. How many tiles of side 0.3 will be needed? Because we don't know it, we use n as the number of tiles, then l as the length of the side of tiles. And if n varies inversely as the square of l, if you look at mathematically, you will see all the text that are dropping down. N varies inversely as the square of l, so that's n is equals to k over k divided by l square. Then k, the subject of formula, that is equals to nl square, because we are looking for k first. When n is 2016, l is 0.4, n we don't know, and l is 0.3. so how are we going to 2016 times 0.4 raised to power 2 is equals to that k, that's n1 l1 is equals to n2 l2. So 2016 times 0.4 raised to power 2 is equals to n times 0.3 raised to power 2. So n is equals to 2016 times 0.4 raised to power 2 divided by 0.3 raised to power 2. You'll be getting 3584. Therefore, the number of tiles for 0.3 is equals to 358 353,584.